this incident, this is the incident part. This is the incident part. This is the incident part wave equation. We are interested in knowing that what will be the E value and H value, that is E scatterer and H scatterer. Okay. Let us see the value of E scattered and H scattered wave. What is going to happen is E scattered and H scattered wave. Remember, this is for incident and previous one that is also for E incident. Now we are going to see for the scatter part that what is going to have a change in the scatter part. Okay. We will have, so the scattered part is given by ESC is equals to 1 by 4 pi epsilon 0 dot k square dot e raised to I k of r by r into n cross p cross n minus n cross m by c. Okay. Over here you can see that this p term is nothing but due to electric dipole moment. This is due to electric dipole moment. This is due to magnetic dipole moment. It will have another derivation to find out the value of scattered E component and scattered H component, but we are not considering that internal derivation. We will take this example with respect to its understanding that this P term is nothing but which is respect to the electric dipole moment. This M term is nothing but which is due to the magnetic dipole moment. Okay, this N is nothing but the propagation vector after scattering. Okay. N is nothing but the propagation vector after scattering. Okay, N is nothing but propagation vector or unit vector, you can say unit vector after scattering. And this is for the spherical wave term. This is for the spherical wave term. Okay, this is for the spherical wave term. And similarly we will have HSC, that is H component with respect to scatter, is nothing but N cross E scattered divided by Z0. Okay, this will be the same as compared to the previous one. Here N is the unit vector. N is the unit vector in the direction of observation, and R is the distance away from scatter. Okay, R is nothing but this R is nothing but the distance away from scatter. Okay, now what we will study is, what we want to study is this is what we have got, the incident E component and H component, incident E field, H field, or incident electric dipole, this P and N relation. But we are interested in finding out the power. We are interested in finding out the power per unit area per solid angle. Okay, we are interested in power per unit solid angle per unit incident flux, means how much of power or how much of flux is incident and how much of power is being radiated. Okay, so going ahead, with this theory, we will now the power radiated. Now the power radiated in the direction n. Remember, the incident wave was having a unit vector n0 and polarization vector psi 0, and now the radiated wave is having the direction n, or that is unit vector n, and polarization epsilon, with polarization psi or epsilon, that is per unit solid angle per unit incident flux. That is power per unit area. This is nothing but power per unit area in the direction. What we want to study is, we want to study the power radiated in the direction after the scattering. You are interested in finding out this power. This is the scatterer, this is the electric field dipole, this is magnetic field, this is the incoming wave. We will have scattering like this. Okay, so this flux, this is incident flux, this is per unit area, power per unit area with some solid angle, okay, we want to find out the power per unit area with some solid angle. Okay, so in the direction n0 with polarization of psi 0 is a, remember this n0 and psi 0 is after the scattering, okay, let us recall me again. This will have n comma psi, this will have n0 comma psi 0, okay. These both terms are related to, this is related to the incident, this is for scatter, okay, this is related to incident and scatter, okay. Don't get confused with this. This is related to incident and scatter, okay. Is a quantity with, this is the quantity with dimensions of area, per unit solid angle, per unit solid angle, and it is called per unit solid angle, and it is called the diffraction. It is called the differential scattering cross section, given by d of this divided by d of tau, okay, or ohm. This is this term. This is for area. This term is for area. This is for area with respect to the solid angle. Okay, area per solid angle. Now we know that we want to find out the power with respect to solid angle, or power with respect to different solid angle. Then this formula will be D by d O is given by n epsilon comma n0 comma epsilon 0 is equals to, okay, d p of SC divided by solid angle by d p of incident divided by solid angle. Okay, power with respect to solid angle and incident, that is scattered power with solid angle, and incident power per solid angle. Okay, now power is nothing but the multiplication of E and H field, which is given by, is equals to 1 by 2 of the real term and the imaginary term, that is r square, that is nothing but the distance of the observation n ESC cross HSC, okay, divided by 1 by 2, this is RE, then N0 E of incident cross of H of incident. Okay, over here this is the real part, RE is the real part. Okay, RE is the real part. We are not considering the real part, we are not calculating that, because that will be some amplitude or something which related to real quantity. We will talk about this electric and magnetic components, this electric field component and magnetic field. This is incident and scattered electric and magnetic. Okay, this n is nothing but the unit vector with the scattered electric component. This n0 is nothing but the unit vector with the incident component, and this r square is nothing but the distance from the observer. Okay, now we also want to define one another thing, that is to calculate, find out this, we will take the complex conjugate of this. We will consider the complex conjugate, and what is going to happen is we will consider the complex conjugate of this H field. Consider the complex conjugate of this H field. But why complex conjugate is been considered? Let us see that for what reason the complex conjugate is being considered. That is, if we want to find out, or if we are considering the circular polarization, if we are considering the circular polarization, okay, it may be a circularly polarized, then we have to consider the complex conjugate, and that is very important to handle the circular polarization. Electric with electric field, electric field with circular polarization is given by E incidence is equals to psi of 0 conjugate dot E incidence of psi 0. Okay, we will just consider the conjugate part. So that is why we are considering this conjugate over here. Okay, we are considering this conjugate over here. Now, what we want to find out is we will expand this part. We will expand this part. This both are unknowns. We have the value of this incident, H incident, we have the value of E incident, we have the value of H incident, we have the value of E scatter, and we have the value of H scatter. We will find out the value of this and we will substitute in this equation. Okay, let us say this is equation number 2. The first one was equation number 1 and 2. This is equation number 1. This is first one was 1a or 1b. This is equation number 2. Let us say this is equation number 3. Okay, this is equation number 2 is important because at last we will find out the value of this and we will substitute in this. We will take care of this. Now what we are doing is we are expanding this term. We are expanding this term. Okay, we are expanding this term. So what we are going to have is we are expanding this term and we will have N0 E incident cross H incident conjugate is equals to N0, substituting the value of psi 0 conjugate E incident, substituting the value of E incident from that assumption. This will have psi 0 cross N0 cross psi 0 conjugate E incidence by Z0. Okay, and psi 0. Okay, okay, so this is nothing but we have substituted the value of H. We have substituted the value of H incidence. Okay, H incidence is nothing but N into E incidence by the impedance. Okay, we have already seen over there. From over here, we will get N0 psi conjugate E incidence, okay, into psi 0 conjugate E incident divided by Z0, okay, into psi 0 of psi 0 conjugate N of 0 minus this bracket part of 0 and 0. Okay. Now from where do this has came? From where do this has came? Let us understand. Let us take this part as A, okay, this part as B, and this part as C. Okay, so this is going to multiply with this term. Okay, this is going to multiply with the first term. So B will be common. Okay, so this is first term is as it is. This is as it is. Okay, this part is from the B, or let us say C. So this is C, okay, and this is B part. So B is constant, A is multiplied with C, and it is written over here. So this epsilon 0, this psi 0, this psi 0 complex conjugate is going to multiply on this part, and N0 is as it is. Okay, we have three cross products. You might have already studied the cross products. Okay, might have already studied the cross product of A cross B cross C. A cross B cross C is nothing but B will be constant, A dot C into B minus of C will be constant, into A dot B. Okay, so this is epsilon 0 and 0 A dot B. Okay, let me write that property. If you have A cross B cross C, then what you can have is B into A dot C minus of C into A dot B. Okay, this is just like this. So C is as it is and it's multiplied by that. Now what we will have is, this is going to be 1, this value is going to be 1, and this value is going to be 0, because they are orthogonal to each other. They are n0 is nothing but the unit vector, and psi 0 is nothing but the polarization vector. Both are orthogonal to each other. That's going to be 0, and at last we used to have is equals to this n0 and n0 will be equals to 1. Okay, remember, so we will have psi 0, that is conjugate dot E of incident square divided by z0. Okay, we will have a square. Now from where do this has come? Remember, this part will become 0, this is 1, so these two term will become square, z0 as it is, and n0 into n0 will be 1. N0 product of n0 will be 1, because both are the unit vectors. Unit vectors product will be 1. This n0 is going to be 1, so that is vanishing. This is multiplied with this, so we have square and z0 as it is. Okay, so this is nothing but for this is nothing but for the lower part, and similarly this is nothing but for the lower part, that is n0 E incident into E incident. Similarly, we will have the upper part, that is the scattering part, and for scattering part also we will have similar kind of thing. Let me write over here. Similarly, we will have for scattering part, that is nothing but n dot ESC cross of HSC conjugate is equals to, we will have n we will have star ESC whole square by z0. Okay, similarly we will have this term. From equation number 2 we have to find out both. This is for, we are finding the denominator. For similarly we will have for numerator. Okay, now substituting both these values in the power equation, we will have power radiated per unit solid angle is given by 1 by 2 of z0 r square sine of conjugate dot ESC whole square divided by 1 by 2 z0 epsilon conjugate 0 epsilon and incident whole square. Okay, substituting in the equation of power with respect to solid angle, substituting the values with respect to power to solid angle. Now over here, remember, this term will get cancelled and this term will become E0 square. Okay, this term is going to become E0 square, because E incident because E incident is nothing but this E incident is nothing but is equals to 0 E 0 e raised to I k and 0 dot x, and we are not considering this term. This will be substituted in this, and this psi 02 conjugate will have 1, and this value will become 1, and E0 will be E square. So this will be totally of E square. This whole term will be totally of E square. Okay? This whole term will be of E square. We are not considering this part. We are not considering time dependent term. So we are not considering that part because that is nothing but time dependent term. It will be more complicated with respect to incident. Okay? And substituting the value of this E scattered now. Now substituting the value of E scattered. If we substitute the value of E incident, it will be E0 square, because E incident is nothing but psi of 0, E0 amplitude, e raised to ik of n0 dot x. We are not considering this part. This psi of 0 to psi 0 of conjugate will be the 1, and E0 will be E0 square. So totally it will have E0 value. Now substituting the value of E scattering, okay, we will have our radiated per unit solid angle is equals to k raised to 4 by 4 pi epsilon 0 whole square. This has came from the E scattered value. Remember E scattered value. Okay. Dot E0 square. This E0 square is this one. This E0 square. This E0 square is nothing but this one. This value. This E0 square is nothing but this value. Okay. Dot R square by R square into sine of conjugate n cross p cross n minus sine conjugate of n cross n by c. Okay, whole square. This is nothing but whole square. Okay, now we will try to expand this part. We will try to expand this part. We will try to expand this part, and we will have what we are going to have is conjugate of psi n dot n p minus n dot p dot n. Okay, where this will be 1, this will be 1. We are expanding this part. Remember, we are expanding this part. Okay, triple cross product. Again, triple cross product is there. So p will be constant, n cross n dot n into p minus this n will constant, n dot p into n. Okay, so this n dot n will be 1, and we will have is equals to only for this part. Remember, only for this part, this is nothing but p conjugate of p minus conjugate of n dot p. Again, this part will become 0. Okay, this part will become 0 because psi is nothing but the polarization vector and n is nothing but the unit vector. So both are orthogonal to each other, and that will be 0. And at last, substituting this value, this value over here, this whole circle, we will get, remember this r square will get cancelled, r square will get cancelled. We will get by d, d of side, d of rho by d ohms, that is nothing but the area, power per unit area per unit solid angle is given by k raised to 4 by 4 pi sine of 0 E0 whole square P plus n cross conjugate of psi dot m by c, okay, whole square, okay, whole square. So this is nothing but the power relation of the scattered wave with respect to unit solid angle, power per unit area per unit solid angle, okay. This is nothing but power per area per unit solid angle, and that is known as differential scattering cross section. This is known as differential scattering cross section, okay. Over here we have a very important relation that you can find, that k is with respect to 10 raised to 4. Over here you can find that k is with respect to 10 raised to 4, while you know that k raised to 4 is equals to omega raised to 4 is equals to 1 by lambda raised to 4, because k is nothing but omega by c. K is nothing but omega by c. We have seen in the previous derivation. K is in the first one, k is omega by c. So it is varies with respect to 10 raised to 4 and inversely of the lambda, and it proves that higher frequency are scattered more as compared to low frequencies, okay. Higher frequencies, this means higher frequencies are scattered more and less frequency scatter less, okay. That is why blue light is having higher frequency. Remember, blue light is having higher frequency, and that is why in sky we used to have blue color, while other lights are less scattered, okay. Electromagnetic waves coming from sun will have scattering inside the atmosphere when they are entering inside the atmosphere, and when they will have scattering inside that, different light will have different wavelength, okay. Different light will have different wavelengths, and in that higher frequencies or shorter wavelengths, if frequencies are high, this will have shorter wavelengths, if frequencies are high or shorter wavelengths, those lights will scatter more, they will more scatter, okay, they will more scatter in different directions with respect to its solid angle. So blue light is more scattered inside the atmosphere, and that is why we will have a blue color in sky, okay. Now over here let us sum up the theory. Hence here the variation of the differential scattering cross section remember the variation of differential scattering cross section with wave, we know that d rho by d ohm is equals to k raised to 4, okay. With wave number as k raised to 4, we have seen that, or in wavelength as lambda raised to minus 4. Okay, in wavelength it will be lambda raised to minus 4 is almost universal constant. This is universal constant. Okay, almost universal characteristics of is the universal characteristics of the scattering of long wavelength. Scattering of long wavelength radiation by a finite system. Okay, by a finite system. Now this dependence on frequency is known as Rayleigh's law. Okay, this dependence on frequency is known as Rayleigh's law. Okay, Rayleigh's law. So this is the end of the first theory, that is the scattering by dipole induced in a small scatterer with respect to the wavelength of light. Lambda is greater than d. Okay, the size of the scatterer is, we have assumed, is small as compared to the wavelength of the light.